All right, guys, now we're going to focus on solving a system of linear equations using substitution. So you will most likely see them where I've got two equations stacked on top of each other. And if it helps you out, go ahead and organize it into that t-table that we talked about throughout the class periods. So I've got y equals 3x plus 2, or plus 10. And y plus 4x is equal to negative 4. The first step in solving using substitution is to make sure that one of our variables is isolated. In this case, our first equation, y equals 3x plus 10, we have the variable y isolated. That means I can take the value of 3x plus 10 and substitute it for y in the second equation. So I could rewrite that as 3x plus 10 plus 4x is equal to negative 4. Now, there is no coefficient on y in the second equation, so I don't have to use the distributive property. I can go ahead and go to the step where I combine like terms. So I've got 3x plus 4x. That's going to give me 7x plus 10 is equal to negative 4. From there, I'm going to subtract a 10 on both sides. That gives me that 7x is equal to negative 14. And the last step will be to divide by 7. So we've got 7x equals negative 14. Divide both sides by 7. And that gives me that x is equal to negative 2. Now I'm not done yet. I'm going to take that value of negative 2 and substitute it in for the x on the first equation. So I'll have y is equal to 3 times negative 2 plus 10. And I will simplify the equation. So I've got y is equal to negative 30 plus 10, which gives me that y is equal to negative 20. So my solution for this first one is going to be negative 2, negative 20. We're going to do the same thing with problem B. So problem B, I have y equals 2x minus 10. And y plus 2x is equal to 6. My first equation is already solved for the variable y. So I'm going to take 2x minus 10 and substitute it for y in the second equation. So I've got 2x minus 10 plus 2x is equal to 6. Once again, the y in my second equation doesn't have a coefficient, so I don't have to distribute. So I can move on to combining like terms. 2x plus 2x gives me a 4x. So I got 4x minus 10 is equal to 6. Now I can just evaluate this equation for the value of x. I'm going to add 10 to both sides. So I have 4x is equal to 16. Divide by 4 on both sides. And x is equal to 4. I now substitute the value of x into my first equation to evaluate y. Let's get y equals 2 times 4 minus 10. And I just solve from here. So I have y is equal to 2 times 4, which is 8 minus 10. So my value of y is equal to negative 2. And therefore my solution is going to be 4 comma negative 2. Now let's move on to problems C and D. In both cases, I do not have a variable isolated on either the left or right hand side, so I need to have an initial first step of isolating a variable. So problem C says x minus y equals negative 3, and 3x plus 2y equals negative 4. So I've got x minus y equals negative 3, and 3x plus 2y is equal to negative 4. In my opinion, it's easiest to start off with that left-hand side because both of those variables technically have a coefficient of 1 and negative 1 respectively. So let's go ahead and just solve for the variable x since its coefficient is already positive and it has a coefficient of 1. That means I'm not going to have to divide by anything. So in order to do that, I'm going to add y to both sides. Now, if I add y to both sides, that y cannot combine with a negative 3 on the right-hand side. That's a variable term and a constant term, so I'm just going to write them next to each other. So I've got x is equal to y minus 3. I can now take this value, y minus 3, and substitute it for x in my right equation, or in my second equation. So I'm going to have 3 multiplied by this y minus 3 plus 2y is equal to negative 4. Now in this case, I do have a coefficient, so my next step should be to distribute the 3, which is my coefficient outside the parentheses. This will give us 3y minus 9 plus 2y is equal to negative 4. Now I can combine like terms. 3y plus 2y is going to give me 5y minus 9 to equal negative 4. I can then add 9 to both sides. That gives me that 5y is equal to a positive 5. Divide by 5 on both sides. So I have a y value equal to 1. But I'm not finished yet. I've got to now substitute that y value into my first equation to solve for x. So I'm going to have x is equal to 1 minus 3. And 1 minus 3 there is negative 2. So therefore my solution for this system is negative 2 comma 1. And remember, your solution is going to be your point of intersection. We're going to do the same thing with problem D. I've got negative 8x plus 6y is equal to 2. Then I have x minus y is equal to 0. My first step is to isolate a variable. Now, we could go about this a couple of ways. I would have to do a lot of division on that left-hand side. So that first equation, I've got multiple coefficients. I've got a negative 8. I've got a 6. Those are pretty big coefficients. So I'm going to choose not to mess with that equation yet. That second equation, though, I've got x minus y equals 0. So how about we just isolate our x variable? In order to do so, I'm going to add y to both sides. So x is going to equal y. So if x equals y, really if we solve for our value of x, then we've also solved for our value of y. So let's go ahead and utilize that ideology. And wherever I see an x in that first equation, I'm now going to substitute it with the value of y. So I've got negative 8 multiplied by y plus 6y is equal to 2. That gives me negative 8y plus 6y is equal to 2. If I combine like terms, that's negative 2y is equal to 2. Then I divide by negative 2. So y is equal to negative 1. If I substitute that value in for y in the right-hand equation, I've got x is just equal to negative 1. So therefore my solution for this system is going to be negative 1 comma negative 1.